Hello, so this is part 2 of the video series pH, Acids, and Logs. pH is known as the power of H. And if you haven't seen the first video, you might want to go back and see it, especially if you're just beginning and you're really confused over the pH in logs. Go back and watch the first video. Otherwise, if you find the first video is too slow for you or too much of a beginner one, this should go a little faster. So just to review, the pH is a measure of acidity in an aqueous solution. Now, note this word here, aqueous. This means that the solvent is water. So we're dealing with a solution made of water. The pH values range from 0 to 14. And they're based on the amount of hydrogen ions present. And the pH and hydrogen ions actually have inverse values. See up here how it says the pH values range from 0 to 14? Well, the higher the pH is, like if it's a pH 14, then the lower the hydrogen ions are. Now, the lower the pH range is, the higher the hydrogen ions are. Now, hydrogen is expressed in a concentration of hydrogen moles per liter, and it's expressed in that concentration, and it's written like this. So you got the hydrogen, the H for hydrogen, and then you have the plus for the fact that it's a positively charged ion. And then these brackets around here mean the concentration of. So the concentration of hydrogen ions, which is the same as hydrogen moles per liter. Now 1 mole of hydrogen ions is the max it can go, and that's expressed 10 to the 0, and that's 1 mole of hydrogen ions, and that just means 1 mole, 1.0 moles. Now this one is 10 to the negative 14 moles. And if you're confused by this, then go back and watch my videos on scientific notation. But 10 to the negative 14th moles of hydrogen per liter, and that's written like this. And the 1, and when we're dealing with pH and stuff, and it's just a 1, you can leave that off and say 10 to the negative 14. That's the same thing. Now pH is measured by the exponent without the negative sign. So here is up here in this problem, the 10 to the negative 14 hydrogen moles per liter equals 10 to the negative 14 right here. So here, right here, this 14 without the negative sign would be the pH. And see, since we ignore the negative sign, this is why the pH is inverse to the hydrogen ions amount. So here we go. Once we get to, here's 10 to the 7th. This whole thing is 10 to the 7th. So this would be the hydrogen ion concentration. And this is the log. The entire negative 7 up here, the exponent, would be the log. Just like this hydrogen concentration number would actually be the anti-log of a logarithmic function. And the 10 is the base. So see how many zeros are in front of the 1 here? You got 1, 2, 3, 4, 5, 6, 7. That's what the 7 over here is doing. There's 7 zeros in front of that 1 to push the 1 all the way back as a small decimal point. Now this negative 7 is the log. But if you just take the number itself without the negative on it, that would be the pH. So therefore, if you want to look at this backwards, 7, let me change colors here. 7 down here is the pH, and that would equal, the pH equals the negative log of the anti-log right here. Or, when we're dealing with pH measurements, the hydrogen concentration. Now, as a review for your calculator, you have to select log in order to make this, to do this problem on your calculator. You have to select log, which is down on my calculator, it's right down here. See this log? That's one of 2 functions on that button. So I have to push that button twice. And then when I push the button twice, this word log will appear and the parentheses will open. And within those parentheses, that's where you want to enter in the hydrogen concentration. And then you hit enter or equals, and it'll give you a -7. So the pH is just the log, but without the negative sign. And the hydrogen concentration is just the anti-log. So let's do some practice problems. What is the concentration of hydrogen ions? What is the concentration of hydrogen ions in a solution with a pH of 9.0? So I like to list the facts out in a little table down here. So the pH is 9.0. The log is negative pH, which is negative 9.0. The anti-log is the same thing as the hydrogen concentration, and that's what we're looking for, so we don't know what that is. So the hydrogen concentration is always going to be equal to the base plus the negative pH. Or this whole thing would be called the log. So if we're trying to find hydrogen concentration, and the pH is 9.0, we're going to write a negative 9.0. And then you can do that on your calculator, or you can just write it out. It doesn't matter, because what does -9 as an exponent mean when 10's the base? It just means there's 9 zeros in front of the 1 to make it push it past the decimal point. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the hydrogen concentration. Oh, and yeah, so this is the hydrogen concentration. So now let's do it backwards. What is the pH of a solution with a hydrogen ion concentration of 10 to the -4 moles per liter? So the log is negative pH, which is negative, we don't know, that's what we're trying to find out. The anti-log, or the hydrogen concentration, is 10 to the -4, because see, that's from right here. So 10 to the -4 moles per liter. And if you want to find the pH is equal to the negative log of the hydrogen concentration. So the pH is equal to the negative log of 10 to the -4. So now we're going to push that into our calculators. So we need to find the pH. So first we need to do the negative sign which is down here, negative sign, and you hit negative, and a negative will show up here. And then you're going to hit your log button twice to get it over to the log function. And that will automatically put in a little parentheses there. And then you want to put in 10 to the negative 4. Well, right here underneath the log button is a 10 to the exponent key, and you also have to hit that twice. So 10, and then it gives you the option to enter the exponent in, and you do negative 4. And then you just hit equals. So let me put that up on my calculator. So negative log of 10 to the negative 4 is 4. So the pH is 4. Here's another one. What is the pH of a solution with a hydrogen ion concentration of 5 times 10 to the negative 6 mole? So the log is negative pH. The anti-log, or the hydrogen concentration, is 5.0 times 10 to the negative 6. In order to find the pH, we need to take the negative log of the hydrogen concentration, which is this. So pH equals negative log so we just have to punch that into the calculator. So first we hit the negative key down here, and then you punch this twice so you can get log. So it'll say negative log and open up parentheses. Then you type in 5, and then remember how to do in scientific notation when you want it to go times 10 to something, you type in E, the double E right there. And then you just put in the negative 6. So negative again down here, and then 6. And then you hit enter. And let me pull that up on my actual calculator. So you end up getting 5.3010299996. So the pH is 5.3010299996.